Welcome everyone to the solving of Edexcel IAL Pure Mathematics 4 P4 May 2025 prediction ideas. First question, they have asked us to expand this expression where modulus of x is less than 4 over 3 in ascending powers of x up to and including the term in x squared, and we need to simplify each terms. So we can write this as 4 minus 3x to the powered 0.5, negative 0.5. Now in order to apply the formula, the binomial expansion formula, the expression must be in this term, 1 plus ax to the powered negative 0.5. So we need to turn this 4 into 1. So in order for that, we need to take a 4 as common. Now since the power is negative 0.5, there will be a power of negative 0.5 on the 4. So this will become 1 minus 3 over 4x to the power negative 0.5. Now I can write this 4 as half. So now if we apply the formula, it should look something like this: 1 plus minus 0.5 times negative 3 over 4x plus minus 0.5 times minus 0.5 minus 1 divided by 2 factorial times negative 3 over 4 whole squared. 3 over 4x whole squared. And we can stop the expansion to this point because we only need the term in x squared. So this will be half times 1 plus 3 over 8x and plus 27 over 128 x squared. So now if we simplify this, this will be half plus 3 over 16x plus 27 over 256 x squared. So that is it for the first part. Now in the second part, hence or otherwise, find the first three terms in the expansion of x plus 8 over root over 4 minus 3x. So we can write this expression as x plus 8 times 4 minus 3x to the power negative 0.5. So now if we take this expression and write it as x plus 8 4 minus 3x to the power negative 0.5, and then we can write the second term as half plus 3 over 16x plus 27 over 256 x squared. So now if we multiply it by x, so that's x over 2 plus 3 over 16 x squared. Now if I multiply this x with 27 over 256 x squared, it will be x cubed, which is probably the fourth term in the series, which we do not need. We only need the third term. I mean, we need up to three terms of the series. So we can just skip that and move on to this multiplication. So that's plus 4 plus 3 over 2x plus 27 over 256 divided by 8 gives us 32 squared. So the final answer should look something like this. So it's 4 plus 2x plus 33 over 32 x squared. So that is it for question 1. Now moving on to the second question. The diagram shows an inverted cone filled with liquid paint. An artist cuts a small hole in the bottom of the cone, and the liquid paint drips out at a rate of 16 centimeters cubed per second. So first of all, we know that dV over dt is given as 16. So that is 16. Now we have to find out dV over dH as 4 over 9 pi h squared. Now as you can see that the volume of cone looks something like this, 1 over 3 pi r squared h. But as you can see that in the equation there are no values of r. So what we can do is that we need to write r in terms of h. But we have an information, it's that the radius, when the radius is 10, the value of height is 15. So we can say that r is equals to 10, h is equals to 15. So I can say that, well, I can write 15 as 15 over 10 times 10. And I know that the value of 10 is r. So it's basically 3 over 2r. So I can say that r is equals to 2 over 3 of h. So no matter what, r will be always equals to 2 over 3 of h. So we know that the volume is equals to 1 over 3 pi r squared h. And we can replace r with 2 over 3 h whole squared times h. So this is equals to 4 pi divided by 27 h cubed. Now if I differentiate this, so dV over dH, this will be equals to 4 pi h squared divided by 9. So that is what they have asked us to show. Now in the second part, we need to find an expression for dH over dt. Now we know that dV over dt is 16. They have given us this in the question. Now if I want to find out dH over dt, I can write this as dV over dt multiplied by dH over dV, because you can see that the dV's cancels each other out. So we're left with dH over dt. Now dV over dt is equals to 16, and dH over dV will be the inverse of dV over dH, which is 9 divided by 4 pi h squared. So this is equals to 36 divided by pi h squared. But there is a slight there will be a slight difference. It's that the liquid paint drips out at a rate of 16 centimeters cubed per second. So there will be a minus sign in the front of dV over dt. So there will be a minus sign in this part. So this is the final answer. Alright. Now moving on to the second part, the third part of the question. Solve the differential equation in part B giving t in terms of h. Alright. So we know that dH over dt is equals to negative 36 over pi h squared. Now we need to make t the subject. So first of all, we need to separate the variables. So this will be pi h squared times dH equals negative 36 times dt. And then the second step would be to put an integral sign on both sides of the equation to keep it balanced. So this will be pi h cubed divided by 3 equals negative 36t plus c, or you can add the plus c at the very end. So the value of t will be equals to pi h cubed divided by 3 times 36, which is 108, negative 108 plus c. So that is the value of t. Now there should be an information to find out the value of c. Now the diagram shows, so initially it was filled with liquid paint, and when an artist cuts a small hole in the bottom of the cone, the liquid paint drips out at a constant rate of 16 centimeters cubed per second. So initially, when the value of t was 0, the value of h was 15. So that is our information. We can work with this to find out the value of c. So when t is 0, the value of h is 15. So it's 15 cube over 108 plus c. So from this we can find out the value of c. So the value of c would be 125 pi over 4. So finally we have an equation which is t equals 125 pi over 4 minus pi h cubed divided by 108. So this is our general solution to the differential, the particular solution to the differential equation. Alright. Now we need to find the length of time it takes for the depth of the paint to fall to 7.5 centimeters. So basically, when the value of h is 7.5, we need to find the value of time taken. So we can just substitute the value of h into this equation. So the value of time is about 85.9 seconds. So that is the answer for this part. Now moving on to the next part. Find the length of time when the cone is half filled in terms of volume. So in terms of volume, we first need to find out the initial volume. So when the volume is full, I think we have an equation for volume. Yep, we have an equation for volume that is 4 pi h cubed over 27. So initially the height was 15. So that's 4 pi 15 cubed over 27. So this is the full volume. Now we need to find out the half volume. We know that V half will be equal to half of the full volume, that is half times 4 pi 15 cubed over 27. And we can also write this volume as 4 over 27 pi h cubed. So we can, from this equation, we can find out the value of h when the volume was half. So that's half times 4 pi 15 cubed over 27. So as you can see that these two cancels out, and this one also cancels out. So from this we can find out the value of h. So the value of h is around 11.9. So when h is 11.9, we can find out the value of t from this equation. So it's 125 pi by 4 minus pi h cubed divided by 108. Pi 11.9 cubed divided by 108. So the value of t is 97.8 seconds. So that is all of the answers to question 3. Question 2. Now moving on to the third part of the question. The diagram shows part of the curve y equal 3 e to the power cos x sin x. The curve has a rotational symmetry of order 2 about the origin, which means that with this line we can know that if this has an area of x, this will also have an area of x. Using the substitution u equal cos x, find the exact value of the total area bounded by the curve and the x-axis between the x equals negative pi and x equals pi. So before doing anything, we need to differentiate the substitution equation. So we know that u equal cos x, so du over dx should give us negative sin x. And the next step would be to make dx the subject. So we get du over negative sin x. So these are the first two steps, and the second step, the next step would be to find out let me just write down the integral. The integral would look something like this: 0 to pi 3 e to the power cos x sin x dx. Now, as you can see that these are values of x, but we need the values of u when the value of x is 0. So when the value of x is 0, the value of u is also 0. And when the value of x is pi, the value of u is minus 1. Oh wait, when the value of x is 0, the value of u is 1. Not 0, it's 1. So now we can write this integral as minus 1 to 1. And there's another thing, we need to find both of these areas. Now since both of these areas have the same magnitude, we can multiply it by 2. So the integral would look something like this: 3 e to the power cos x multiplied by sin x, and we can replace dx with du over negative sin x, or negative du over sin x. Now what we can do is that cancel out these two. So finally we get negative 2 integrate minus 1 to 1 3 e to the power, and we know that u is equals to cos x, so this is 3 e to the power u du. Now we can integrate this very easily. So the integration would look something like this: 3 e to the power u minus 1 to 1. So it's basically 3 e to the power 1 minus 3 e to the power minus 1. That is basically 3 over e. Okay, so there was a slight problem with the question, not the question, basically my answer. The limit should be 1 to minus 1, not minus 1 to 1, because the lower limit is 1 and the upper limit is negative 1. It's 1 to minus 1, 1 to minus 1. So it should look something like this: 3 over e minus 3e. Now if I multiply it by 2, it should look something like this: 6e minus 6 over e. So that is the answer to this question. Moving on to the fourth question of the paper. First of all, we need to solve the equation ln 3x plus 1 equals 2. So the first part is ln 3x plus 1 equals 2. If we take this ln to the right hand side of the equation, this becomes 3x plus 1 and the right hand side becomes e to the power 2. So the value of x is e to the power 2 or e squared minus 1 divided by 3. Now moving on to the second question, we need to prove by counter set of value that the statement ln 3x squared plus 5x plus 3 is greater than or equals to 0. For all real values of x is false. So this is a counter example, but there is a twist. There is 4 marks for this question. Usually for counter examples, there is only 1 mark or a maximum of 2 marks. So what we need to do, I guess we need to solve this inequality and find the values of x for which this is not equals to 0. I mean, it is not equals to 0 or greater than 0. So let's say if we take, let's say ln 3x squared plus 5x plus 3. 3x squared plus 5x plus 3 is less than or equals to 0 because that is what we're trying to achieve. So if we take this ln to the right hand side of the equation, this becomes e to the power 0. And we know that e to the power 0 is equals to 1. Now 3x squared plus 5x plus 2 is less than or equals to 0. So for this expression to be 0, the range of values of x must be greater than or equal to x or less than or equals to negative 2 over 3. Now you can take any values of x in this range. Let's say we take x equals negative 1 over 2. So the value of ln 3x squared plus 5x plus 2 will be equals to ln 1 over 4. And I think ln 1 over 4 is a negative value. Yep. So it's a negative value, which is minus 1.386 and so on. So this proves that the statement is false. So statement is false. So that is it for this question. Now moving on to the next question. The curve C is described by the equation this, where m is a negative constant less than 0. Find dy over dx in terms of x and y. So we need to apply implicit differentiation to this, which means that we need to differentiate every single term separately. So if we differentiate this, we get 6x, and if we differentiate this term, we get negative 4y. Now since this has a y in the variable, you need to multiply it with dy over dx also. And if we differentiate this, we get 2. And differentiating this will give us negative 3. And since there was a y involved, we need to multiply it with dy over dx. And differentiating this will give us 0. Now we just need to make dy over dx the subject. So we can say that dy over dx will be equals to 6x plus 2 divided by 4y plus 3. So that is the answer to the first part of the question. Now moving on to the next part. The point Q lies on C given that the normal to C at Q has equation y equals negative 7 over 2x plus 1. Alright. So this is the normal to C at point Q. Let's say that the curve looks something like this. And this is the point Q. So the normal would look like this, which has a gradient of negative 7 over 2. So the tangent will look something like this, which will have a gradient of 2 over 7, because the product of two perpendicular the product of the gradient of two perpendicular lines will be always equals to -1. So we can say that at point Q, the value of dy over dx is 2/7. So we can say that 6x plus 2 over 4y plus 3 is equals to 2/7. So from this we will get an equation. This will be 42x plus 14 is equals to 8y plus 6. Now if we make y the subject, we get 42x plus 8 over 8. Now this is the y coordinate of point Q, which means that if I substitute the y coordinate of point Q into this equation, because this point Q lies on both the normal and the tangent, so I can say that -7/2x plus 1 is equals to 42x plus 8 divided by 8. I will get the x coordinate of point Q. So from this, the x coordinate will be equals to 0. Now the x coordinate is 0. Now let's find out the y coordinate. We can substitute the value of x into either one of these two equations. So let's just substitute it in this equation. So that's 42 times 0 plus 8 divided by 8. That will give us 1. So point Q has a coordinate of 0 and 1. Now bear in mind that the point Q also lies on the curve C, which means that we can also substitute this coordinate into this equation. So let's substitute it into this equation. So that's 3 0 squared minus 2 1 squared plus 2 times 0 minus 3 1 equals m. So from this we will get the value of m. So the value of m is equals to -5. So that is it for this question. Moving on to the sixth question. So we have an equation for line L1 which looks something like this. Now point A lies on L1 where mu equals 1. Find the coordinates of A. So if we substitute mu equals 1 into this equation, we will get the coordinates of A, or you can say that we will get the OA vector. So the OA vector will be equals to 3 5 0. So that is the OA vector. Now point P has position vector 1 5 and 2, or you can say that this is equals to OP vector. The line L2 passes through the point P and is parallel to the line L1. So it passes through point P and it is parallel to the line L1. Now L1 has a direction vector of -5 4 and 3. So we can say that the line L2 has an equation of, in the first part we need to write down the coordinate of point P, which is 1 5 and 2, plus lambda, the direction vector. The direction vector is parallel to line L1, so we can say that the direction vector is equals to -5 4 and 3. So that is basically the equation of L2. Now we need to find the exact value of the distance AB. So basically we need to calculate the distance AB. So that is pretty easy. We just need to use the formula. which is x2 minus x1 whole squared, that is 3 minus 1 whole squared, plus y2 minus y1 whole squared, 5 minus 5 whole squared, plus z2 minus z1 whole squared, that is 0 minus 2 whole squared, root over. So this is equals to 2 root over 2. Alright. Now the acute angle between AP and L2 is theta. Find the value of cos theta. So we need to apply the scalar product rule. So the scalar product rule says that if we have the AP vector and multiply it with the direction vector of line L2, which is minus 5, 4 and 3, this will be equals to the modulus of AP vector multiplied by the modulus of the direction vector times cos theta. So first of all, we need to find out the AP vector. We can say that the AP vector is equals to OP minus OA vector. So OP vector is 1, 5 and 2, and OA vector is 3, 5 and 0. So it's 3, 5 and 0. So this is equals to negative 2, 0 and 2. So it's basically negative 2, 0 and 2 multiplied by negative 5, 4 and 3 is equals to the modulus of AP vector. We know that the modulus of AP vector is 2 root over 2. So it's 2 root over 2 multiplied by the modulus of direction vector. So the modulus of direction vector will be negative 5 whole squared, which is 25, plus 4 squared, which is 16, plus 3 squared, which is 9, and root over this whole thing, times cos theta. So in order to multiply these two vectors, we need to multiply the corresponding values and add them up all together. So it's 10 plus 0 plus 6 is equals to 2 root over 2 times 5 root over 2 cos theta. So from this we can find out the value of cos theta. So that's 16 divided by 2 root over 2 times 5 root over 2, which is equals to 4 over 5. So this is the value of cos theta. Alright, now in the next question, a point E lies on the line L2 given that AP is equals to PE. So let's assume that this is the line L2, this is L2, and let's assume that this is point A and this is point P. Oh wait, point A does not lie on L2, I guess. Point A lies on L1. Right. Point P lies on L2. So let's assume that this is point P and this is point E. So this will be point P and this is point P, and this is point A. Now this is theta and AP is equals to PE. So if this is 2 root over 2, this will also be 2 root over 2. Now we need to find out the area of this triangle. Now we know that cos theta is equals to 4 over 5. So from this we can find out the value of sine theta. So cos theta is adjacent divided by hypotenuse. So this is 3. So the value of sine theta is equals to 3 over 5. Which means that the area is equals to half AB, that is 2 root over 2 whole square, times sine theta. And the value of sine theta is 3 over 5. So the area is equals to 12 over 5 units squared. So that is the answer for this part. moving on to the next part. Find the coordinates of the two possible positions of E. Okay. So we do not know the value of point, we do not know the coordinate of point E. But what we do know is that point E lies on line L, which means that I can say that the value of the coordinate of point E will be equals to 1, 5, 2 plus lambda minus 5, 4, and 3. Now I need to find out the PE vector. I can say that the PE vector is equals to OE vector minus the OP vector. So we know that the OE vector is minus 5 lambda plus 1 and 4 lambda plus 5 and 3 lambda plus 2. This is the OE vector minus the OP vector. OP vector is 1, 5, and 2. So it's 1, 5, and 2. So this is equals to minus 5 lambda and 4 lambda and 3 lambda. So this is the PE vector. Now we can say that the modulus of P is equals to 2 root over 2, as they have mentioned in the question. The length of PE is equals to the length of AP. So I can say that this is equals to negative 5 lambda whole squared plus 4 lambda whole squared plus 3 lambda whole squared. And root over is equals to 2 root over 2. Now if I remove this as square root to the right hand side of the equation, this becomes squared. So this is equals to 50 lambda squared is equals to 8. So there will be two values of lambda. One of the values will be plus 2 over 5 and the other value will be minus 2 over 5. So it's plus or minus 2 over 5. Alright. So when the value of lambda is 2 over 5, let's find out the position of point E. So when it's plus 2 over 5, the position of point E would be minus 1 and 33 over 5 and 4, 16 over 5. So that's for lambda equals 2 over 5. And when the value of lambda is negative 2 over 5, let's find out the coordinates of point E. One of the coordinates will be 3 and the other one will be 17 over 5 and the last one would be 4 over 5. So these are the two possible positions for point E. So that is it for this question. Now moving on to the next question. An underground storage tank is being filled with liquid as shown in the diagram. Initially the tank is empty. At time t hours after filling begins, the volume of liquid is V meters cubed and the depth of liquid is H meters. It is given that V equals 4 over 3 pi 4 over 3 H cubed. So this makes our work much easier. Now the liquid is poured in at a rate of 20 meters cubed per hour. So what we know from the question is that they have given us dV over dt, which is equals to 20. Liquid is lost at a rate proportional to Hs squared. Okay, so liquid is lost at a rate proportional to Hs squared, which means that, okay, so we'll come back to this later. When H is equals to 1, dH over dt is 4.95. So this is the value of dV over dt. of dv over dt, it is the input value and the output value is proportional to hs squared. So dv over dt output is equals to k hs squared. So if I want to find out the overall value of dv over dt, it's 20 minus k hs squared. So that's the overall value of input. Now show that h satisfies the differential equation dh over dt. So basically we need to find dh over dt. Now in order to find dh over dt, I can write it like dv over dh, or not dv over dh, dv over dt times dh over dt over dv, because as you can see that the dv's cancels each other out, so we're left with dh over dt only. So one of the things we know that v is equals to 4 over 3 h cubed. So dv over dh is equals to 4 h squared. So now if we substitute the values into this equation, the value of dv over dt is 20 minus k h squared. Yep, so it's k h squared times dh over dv is the inverse of this value, so it's 1 over 4 h squared. 1 over 4 h squared. Now we know that when the value of t is 1, when the value of, not the value of t, when the value of h is 1, the value of dh over dt is 4.95. So that's 4.95 equals 20 minus k times 1, which is k, times 1 over 4. So from this we can find out the value of k. So the value of k is 0.2. Right. Now we need to show that h, okay, so finally we need to write the final equation, which is dh over dt, dh over dt is equals to 20 minus 0.2 h squared times 1 over 4 h squared. Alright, so we need to multiply it with 1 over 4 h squared. So that gives us 5 over h squared minus, so 0.2 divided by 4 gives us 1 over 20. So it's 1 over 20. So that is the answer to the first part of the question. Now for the second part, we need to verify that 20 h squared over 100 minus h squared is identical to negative 20 plus 2000 over 10 minus h over 10 plus h. So showing this in this format, bringing the left hand side to the right hand side, is much harder. So we're gonna work with the right hand side and we will show that this is equals to the left hand side. This is much simpler. So if we work with that, which means this is part B. So minus 20 plus 2000 over 10 minus h and 10 plus h, I can write it as 100 minus h squared. So this is equals to 2000 minus 2000 plus 20 h squared divided by 100 minus h squared. So this is equals to 20 h squared divided by 1000 minus h squared, 100 minus h squared, which is equals to the left hand side. So that is it for this part. Now moving on to the next part, hence solve the differential equation in part 1, obtaining an expression for t in terms of h. So this is the second order differential question. Okay. So we know that dh over dt is this equation, dh over dt is this equation. So if we want to write this equation in this form, which is 20h squared, and this is 5 times 20 is 100, so it's 100 minus h squared. So first of all, we need to separate the variables. We can write this as 20h squared divided by 100 minus h squared dh is equals to dt. And then what we need to do, we need to put an integral sign on both sides of the equation. Alright. Now integrating this will be much harder, but what we can do is that we can write it in this format. That is negative 20 plus 2000 over 100 minus h squared. So negative 20 plus 2000 over 100 minus h squared. So 100 minus h squared, we can write it as 10 plus h and 10 minus h dh. And integrating this, we know that there is a 1 in this part. Integrating this will give us t. Now integrating this will be much harder, but we can write it as partial fractions. We can say that 2000 over 10 plus h and 10 minus h is equals to a over 10 minus h plus b over 10 plus h, or a over 10 plus h plus b over 10 minus h. So this is 2000 equals a 10 minus h plus b 10 plus h. Now there are two ways of finding out the values of a and b. The first one is the comparing the coefficients. That is much more lengthy, but there is a clever method to this. We need to take clever values of h. So first thing we need to do is that we need to eliminate the values of a and the value of b. We need to eliminate one of the variables. Let's say that I want to eliminate the variable a. So in order to eliminate the variable a, this must be equals to 0. So when the value of h is 10, this is equals to 0. So a times 0 is equals to 0. So we can say that 2000 is equals to b 10 plus 10. So the value of b is, okay, so the value of b is 10. And then what we need to do is that we need to eliminate this variable. In order to eliminate this variable, this value must be equals to 0. If we substitute the value of h as negative 10, this whole part becomes 0. So let's substitute the negative 10. So 2000 equals a 10 minus 10, that is 10 plus 10. So the value of a is also 10. So finally we can write this as negative 20 plus 10 over 10 minus h plus 10 over 10 plus h dh equals t. So the integral of this will be negative 20h, and the integral of this will be minus 10 ln 10 minus h. and the integral of this will be equals to plus 10 ln 10 plus h is equals to t, and you can add a plus c at the very end. So let's add the plus c in this part. Now we just need to find out the value of c. Now we know that initially the tank is empty, which means that when t equals 0, the value of h is 0. So let's substitute that into this equation. So h is 0, which means c minus 10 ln 10 plus 10 ln 10 is equals to t. So the value of is equals to 0. So the value of c is equals to 0, which means that t is equals to 10 ln 10 plus h minus 10 ln 10 minus h minus 20h. Or you can also keep it like this: 10 ln 10 plus h divided by 10 minus h minus 20h. So that is it for this equation. And that is all the answers to question 7.
Are you still stuck in chapter 1? While exams race closer, watched a dozen videos but still receiving the same marks in tests? Well, it's not you, it's the method. Let's fix that. Now welcome to Exam Essentials, where every second counts and every session hits. We usually offer 2 signature courses for O and A level students. The number 1 is the High Impact Crash Course. It is launched 5 to 6 months before every exam session. Whether you're a 2025 or 2026 candidate or any future sessions, this course is your fast track to astonishing results. And the number 2 course is our complete 1-year course. It is designed for 2026 and 2027 candidates or beyond. Now to know more, check the description box or text us directly on WhatsApp or our Facebook page. Stop struggling, start scoring. Your true potential is waiting. The time is now.
Now moving on to the next question. Part of the design of a stained glass window is shown. The 2 loops enclose an area of blue glass. The remaining area within the rectangle ABCD is red glass. Okay, the loops are described by the curve with parametric equations, this and this. Now we need to find the Cartesian equation of the curve in the form y square equals fx. So first of all, if we take the equation x equals 3 cos t, and let's take the another equation, which is y equals 9 sine 2t. We can write 9 sine 2t as 2 sine t times cos of t. And we can rewrite this equation as 18 sine t times cos of t. Now we need to bring x into this equation. We know that x is equals to 3 cos t. If we make cos t the subject, we get x over 3. So that gives us 18 sine t times x over 3, which is equals to 6x times sine of t. Now we need to get rid of sine t. In order to do that, first of all, as you can see in the question, it must be in the form y square equal fx. So we need to square this whole thing. So this is squared and this is squared. So this is equals 36 x squared sine squared t. And we can write sine squared t as 1 minus cos squared t. And we can replace cos squared t with x squared divided by 9. So x squared divided by 9. So that gives us 36 x squared minus 4 x to the power 4. So that is the answer to this part. Moving on to the next part, show that the shaded area enclosed by the curve and the positive x-axis is given by this, stating the value of the constant a. So first of all, we know the lower limit, but we do not know the upper limit. But we know that in this point, the value of y is 0. So we can say that y is equals to 0. That is 36 x squared minus 4 x to the power 4 equals 0. Now if we take 4x squared as common, we get 9 minus x squared equals 0. So we get two values of x. And not two values of x, we actually get three values of x. Plus and minus 3 or x equals 0. So in this point, we know that x will be positive 3. And this is the negative 3 part. So now we just need to carry out the integration. So we can say that the integration is 0 to 3 y of dx. And we can, since this is a parametric integration, we can write dx as dx over dt multiplied by dt. Now these are the values of x. Since there's a dt in this equation, we need to write these values of x in terms of u. So when x is 3, the value of u is 0, and when x is 0, the value of u is pi over 2. So we can write this as integrate pi over 2 and 0. And y is equals to 9 sine 2t. And dx over dt would be minus 3 sine t. So that's minus 3 sine t. dt. Okay. So this is equals to negative 27 integrate pi over 2 and 0 sine 2t multiplied by sine t dt. Okay, so now this gives us a negative value. We can also write this integral as 27 integrate 0 to pi over 2. If we flip the limits, the answer becomes negative. So minus 1 times minus 1 is positive 1. So sine 2t times sine of t dt. So we can say that the value of a is equals to 27. So a is equals to 27. Now in the next part, we need to find the value of this integral. Now we just need to integrate this. This is part C. So 27 integrate 0 to pi over 2. And we can write sine square t as 2 sine t times cos of t multiplied by sine t dt. And if we simplify this, 27 multiplied by 2 will give us 54. So that's 54 0 to pi by 2 sine squared t cos t dt. Now we need to apply the reverse chain rule. Now if you take a term such as sine cube t and differentiate this, we will get 3 sine squared t and cos t. So this is the differentiation of sine cube t. Now as you can see that these two terms are very identical. There's only the 3 missing in this part. So if we take the 3 from 54, so this is 18 times 0 to pi over 2, 3 sine squared t and cos t dt. Now if we integrate this term, we will get sine cubed t. So this is sine cubed t, 0 to pi over 2. So now we just need to carry out the integration. So that's 18 times 1 minus 0. So the area is 18 units squared. So that is the answer for this part. Moving on to the next question. The sides of the rectangle ABCD are tangents to the curve that are parallel to the coordinate axis. Now find the total area of the red glass. So this region, this part of the region, this loop represents the blue glass, and this region represents the red glass. So we need to find the area of this region. Right. We know that one of these areas is 18. So the area of the blue glass is equals to 18 times 4. That is 72 centimeters squared. Now we need to find the total area, the area of this rectangle. We know that this is 3 and this is minus 3. So this length is equals to 6 centimeters. Now we just need to find out this length. Now we know that at this point, the value of dy over dx is equals to 0. So we can say that dy over dx is equals to 0. And we can write dy over dx as dy over dt multiplied by dt over dx equals 0. So dy over dt gives us 18 cos 2t, and dt over dx gives us 1 over minus 3 sine t equals 0. So this is actually minus 6 cos 2t over sine t equals 0. So we have an equation which is 6 cos 2t equals 0. So the value of t is pi over 4 in this case. So cos 0 divided by 2, yep, this is pi over 4. So when t is pi over 4, that is the maximum value. So we can find out the y coordinate using this equation. 9 sine 2 times pi over 4. So that gives us 9. So if this is 9, this is 9, this will be negative 9. So the length of this will be 18 centimeters. So we can say that the area of the total value, the total region, is 18 times 6. And if we subtract the area of the blue glass, we will get the area of the red glass, which is equals to 36 centimeters squared. So that is it for this question, and I hope you guys enjoyed the video so far. Don't forget to like, share, subscribe, and leave a comment. And I'll see you guys in the next video.